In the last episode, Sasha and Keone graphed a parabola with a p-value of 1/4. In this episode, they will graph a parabola with a greater p-value, p equals 1/2. As they graph the parabola with a p-value of 1/2, they explore how it compares to the parabola with a lesser p-value of 1/4.
And then go ahead and graph the parabola when p equals 1/2.
Okay, so we're going to start off by plugging it into our big equation. Okay, so we're going to say this one is in this color. So we're going to say y equals x squared over 2. And we got that because we plugged in our 1/2 into this equation for p.
Mm-hmm.
So now, do you want to make the line? Right, because we said it was going to be along. We said it was going to be along this one?
Yeah, I think so.
Okay.
Yeah.
So we said it's going to be somewhere along this one.
Why is that?
Because that's 1/2.
Because in this one, when our p was 1/4, it fell along. Like it was on 1/4
Got it.
up, so then we just figured it would be the same.
Cool.
Okay. All right, so then we said that our y is going to be 1/2. So we're going to say 1/2 equals x squared over 2. So then times 2 times 2, which is 1, right?
1.
1 equals x squared, so square root, x equals 1. Which, does it work? Oh my gosh, it works.
Great.
What's it? What's it works?
It falls along our point.
And what's the coordinates
It's
for
going to
that?
be 1, 1/2.
Now, could you have...
I should know.
Once you did the 1/2, you plugged into the equation. Could you have also used the parabola definition to get the 1?
Yes. Right? Because
Walk me through that.
Because it would have to be the equal distance from the focus and directrix. So whatever that was.
Put your little pen along. So what is the distance from the point to the focus?
Right. That one, right?
Right there?
Yep.
Okay, good. And that one.
Yeah, how did you
Everything's
know
very
that
messy.
distance was 1?
Just asking you a question. This distance right here is 1?
Well, like from where, because our directrix is going to be different. Right?
Where is the directrix of the new one going to be?
Now it's going to be 1/2 away from the
Right. Am I right?
Can you draw in the directrix
Totally.
for the new one?
Oh. Our new directrix is right there.
And then our new focus is right.
Wait.
Oh gosh, nope, not there.
Yeah.
And it's right there.
Right here. That's a new focus.
Yeah.
Okay. So what's the p-value? What's the distance from the origin to the focus?
1/2. So then that's 1/2, and then that's 1/2.
Okay. And what's the coordinates for the focus?
For the focus is 0, 1/2.
Okay.
Did you notice how Sasha and Keone moved back and forth between using geometry and algebra to determine that the point 1, 1/2 is on the new parabola? They used the geometric information that when the distance between the focus and vertex for the red parabola was 1/4, there was a point on the parabola that was also on a horizontal line that went through the focus and was 1/4 of a unit above the x-axis. So they figured when p equals 1/2, there would be a point on the parabola that is also somewhere along a horizontal line that is 1/2 of a unit above the x-axis. That means that the y value for this point will be 1/2. To find the x value of the point on the new parabola with a y value of 1/2, Sasha and Keone switched to algebra. They found the equation for the new parabola by using the general equation y equals x squared divided by 4 times p. They replaced p with 1/2. Because 4 multiplied by 1/2 is 2, the denominator is 2, and the equation for the new parabola is y equals x squared divided by 2. Sasha and Keone used this equation to find the missing x value for the point on the new parabola when y is 1/2. Sasha and Keone returned to geometry to make sense of the point 1, 1/2. They argued that it fits the geometric definition of a parabola. The distance from the point to the directrix is 1 unit, because it is 1/2 of a unit from the point to the x-axis and another half of a unit from the x-axis to the directrix. The distance from the point 1, 1/2 to the focus is also 1 unit. Because the point 1, 1/2 fits the definition of a parabola, it will be on the new parabola. Next, Sasha and Keone find other points on the new parabola.
Go ahead and find some more points on the parabola so you can fill it in.
This is getting
So then we'd have another point right here.
And plug in
And plug in 2.
2.
So when 2 equals 4 over 2, so 2.
2 over 2. 2
2
times 2.
2 and 2, right? And
Can you
3.
label those?
Yeah. That's a negative right there.
Totally is.
And then this is a 2 and 2. Yes. Right?
Yeah.
Yeah.
You know, I'm kind of interested that the point for the first parabola, you have one that's 2, 4.
Mm-hmm.
What do you think the x value would be for the y to be 4 for this new parabola?
For when it's 4? I'm just wondering.
Or when y is 4?
When y
When
is
y is
4?
4?
Mm-hmm.
Okay, so when it's up here, which one is it going to be? It's going to be out here.
Why? Why? Yeah. Why do you think that?
Because we know it's going to be, because our prediction was right, it is wider.
Like right there?
A little bit wider, right?
Here?
Sure.
Do you think you
Or like
could?
from here?
it's
I don't
like a
know,
little-
maybe.
Do you think I could find it precisely?
Yeah. If we plug it in.
When y is 4, so 4 equals 4 squared is 8. Right? Or
Why don't you
I don't
scroll down, Keone, and write that,
Write
and write what you're plugging into and what the
okay, so you
calculation
said when
is.
y is 8, right?
Y is 4.
Oh, y is 4.
What's the equation you're plugging into?
Right here.
Ah, okay.
So then x squared, oopsies. X squared over 2.
Over 2, right?
So times 2 times 2.
X equals x squared. Square root.
You know it?
You can use your calculator.
Yeah.
Okay. So you do 8, and then, which one was that one? That one, right? Okay.
2.8.
Yeah. We got when y equals 4, x equals 2.8.
So how would you say that coordinate pair?
2.8, comma 4.
Okay, can you try to graph that?
Right here.
Sure.
Right there?
Sure.
Ish.
Yeah.
And up here is like right here.
Does that fit your expectation?
And it does, it's still wider.
Yeah.
Why don't you sketch in the parabola and label that point?
Okay. My gosh, where is the origin?
Right there.
Okay. And it's to that one.
Mhm.
Do you want me to do it?
Yeah.
Okay. And then, and this one is, which one is it? It's like there.
Negative 2.8 and 4 up. Yeah, right there. Wait. 2.8. Yeah. This is 2.8, comma 4.
And then negative 2.8.
Negative 2.8, comma 4.
No, I think you figured out a lot.
Sasha and Keone located 2 more points on the new parabola using algebraic substitution, first letting x equal 2, and then letting y equal 4. They used the symmetry of the parabola to locate 2 more points. They concluded that their prediction had been correct, When the p-value for a parabola increases from 1/4 to 1/2, the parabola becomes wider.